In this video, I will be explaining about binary search algorithm. This algorithm searches for a target value in a sorted input array. That is something to keep in mind, that this algorithm will only work if the array is a sorted one. It can be either ascending or descending order, that does not matter, as long as the programmer knows about this order beforehand. Let's directly jump to an example to understand how this algorithm works. So here I've taken an array of 9 elements. The elements are in ascending order, and let's say our target value is 16. We want to find the index which stores element 16 in it. So the first step of the algorithm is to actually split the array into two equal parts. And that is why the algorithm also has binary in its name. Binary means 2. So to split the array, we first have to find the middle element. To do that, we make use of two variables, L. L stores the index of the leftmost element of the array, which is 0 in this case. And we have one more variable, R, which stores the index of the rightmost element in the array. So this is 8. Then the index of the middle element here is nothing but the average of the two values of L and R. So take the average of two values and we take the floor value of that. It can be a ceiling value also, but make sure that we are consistent across all the iterations of the algorithm. But in this case, I'm taking the floor value. So using this formula, we can find that our middle index is 4. So this is our middle element. And now let's compare our middle element with the target value. So our middle element is actually greater than our target value. Now let's observe something in this array first. All the elements which lies on the left hand side of the middle element are actually smaller than 35, and all the elements which lies to the right hand side of the middle element are greater than 35. So since 16 is smaller than 35, we can conclude from this that our target value has to lie on the left hand side of the middle element. It cannot be in any of these locations. So we can eliminate all these elements from the array. Our target value has to lie on the left hand side of the middle element. So with this, we have completed the first iteration of the algorithm. Now let's repeat all the same steps in one more iteration on the leftover array. So now we have 4 elements left in the array: 3, 9, 16 and 22. L will still be pointing to the same value, 0, but R here has now moved to mid -1. So it has moved to 3. It has moved to this location, right? Now let's repeat the process. We find the mid value, which will be this. So this is the middle value. If we compare our middle value with our target value, we can see that our middle value is less than our target value in this case. So again, what we can say from here is our target value has to lie on the right hand side of the middle element, and we can again eliminate half the array. We repeat the process one more time, and now this time we have only 2 elements left in the array, 16 and 22. R now will remain at the same location, which is 3, but left is now pointing to mid +1 location, which is 2. We use the same formula to find the middle element, which will be this one. And now this time we have hit the bullseye. Now we can see our middle element is actually same as our target value. So we have found the target value in the array, and it is located at index 2. So this is how the algorithm works. In each iteration, we keep on dividing the array by half. So now let's first find the timing complexity before moving into the code, how I've written the pseudocode. Now to find the timing complexity, let's understand something first. So let's say we have an array of n elements. In the first iteration, we eliminate half the array. So after first iteration, we will be left with n by 2 elements. After one more iteration, we again eliminate half the array. So we are left with n by 4, then n by 8, and so on. So we are trying to find the time complexity of this algorithm. So let's say it takes k iterations to find our element. So how many elements are left after k iteration? It will be n to power k. And in worst case, if we will say that there's only one element left in the array when we found the target element, right? That is the worst case scenario, when we have eliminated all the other elements and only one element is left in the array. So we equate this to 2. So this is the worst case scenario here. Now let's simplify this. N equal to 2 power k. Let's take log both sides. Log of base 2, k log 2, 2. I've used a logarithmic property here, and again log 2 with base 2 will be 1, so we can eliminate this. So we can say that k is equal to log 2 of n. So in worst case scenario, it takes log 2n iterations to find the element. And therefore, the tiny complexity or the big O notation of this algorithm is O log n. I have also written the code here, but due to shortage of time, I will not be able to explain it as part of this lecture.